The third thing we have to talk about in our chapter of linear functions is rate of change and how that affects the look of our lines. So by the end of this lesson, you should be able to use rate of change to solve problems, and then you should be able to find the slope of a line. So let's define what rate of change is. Rate of change is a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. So we are going to talk a lot about x's and y's. And if you remember, we said x was an independent variable and y was our dependent variable. So I want you to think of rate of change as change in y divided by change in x. And you know how mathematicians are lazy and we like to abbreviate everything. This symbol here, that triangle, is a delta. It's a Greek letter, but it means change. And because we have x and y talking about our variables, you can think of this as change in your dependent variable divided by change in your independent variable. So let's find the rate of change. The table shows how the tiled surface area changes with the number of floor tiles. Find the rate of change. So you have x's and y's. Rate of change is always going to be our change in y divided by change in x. So let's take a look. How does our y value change? So from here to here, if we're at 48 and we go up to 96, we changed by, we can do a little subtraction here, we changed by 48. Now double check that here to go from 96 to 144, we also changed 48. So the change in our y value is 48 divided by the change in our x. And this one's easy to see. We're going up by 3 every time. So because it's a ratio, it's just a fraction that we can simplify. And the rate of change is 16. So explain the meaning of the rate of change. So the awesome thing about rate of change is because it's a ratio and because it's a fraction, we can simplify it and then get something like this, 16 over 1. Which means that if I change this by 1, I would change this by 16. So if we add 1 and get 10, change this by 1 and add 16, that would give us 160. And we could keep doing this all day long. We could add 1 over here, we could add 16 over here. But what it means is that for every one more floor tile, we have covered another 16 square inches. So part B means one floor tile equals 16 inches squared of our surface area. So let's do one with a graph instead of the table. This graph shows the number of people who visited U.S. theme parks in recent years. Find the rates of change for 2000 to 2002 and then 2002 to 2004. So right here to right here is where we're looking first. So if we take a look at this, remember change in y divided by change in x. So our y values, we went from 317 to 324. So let's subtract those and figure out the difference, and we end up with 7. And then our x values is this down here, and it was 2 years. So we get 3.5 when we simplify that. Now if we do the same thing from 2002 to 2004, 2002 to 2004, it only went up 1 on the y, but it was still 2 years, so 0.5. So explain the meaning of the rate of change. So we got to go over here and look and see. Attendance in millions per year. So when I take a look at this green one that I have here, or from 2000 to 2002, that's 3.5 million more people went to the park. Where between 2002 to 2004, only 500,000 people went to parks. So how are the rates of change differently shown on the graph? And if you take a look, this is 7 times bigger. And if you look at the slope on here, it is way steeper. So rates of change are shown on a graph by the steepness. So a rate of change is constant for a function when it's the same between any pair of points on the graph. So if we go back to this one here, how these were all 48 and these were all 3, that's what we're talking about here. Linear functions have a constant rate of change because it has the same slope all the way through. So determine whether each function is linear and then explain. So what you're looking for is for your x values to be going up by the same amount, and then also your y values to be going up by the same amount. So here, my x values all go up by 3, which is awesome. And my y values, to go from -6 to -8, I have to subtract 2. And if you look, for every single one of these, I'm subtracting the same thing. So that means this function is linear, and it's because you have the same rate of change. Now if we look at this one over here, we'll do the same thing. Let's find the distance between the x values first. So to go from -3 to +1, I add 2, add 2, add 2, add 2. So we're good here. Now to go from 10 to 12, I'll add 2. 12 to 16, though, I add 4. And then I add 2, and then I add 4 again. So this right here is not a constant rate of change. If we were to graph this, it would go up, and then go up more, and then go up, and then go up more. So this would not be a straight line. So it's not a linear function. So let's relate all of this to slope. The slope of a non-vertical line is the ratio of the change in the y-coordinates to the change in the x-coordinates. So you guys have heard these words a million times, rise and run. Because it's that ratio, that's where we come up with rise over run. Slope can be used to find or to describe a rate of change. Slope describes how steep a line is. The greater the absolute value of the slope, the steeper the line is. Because a linear function has a constant rate of change, absolutely any 2 points on a non-vertical line can be used to find the slope. The slope of a line can be positive, negative, 0, or undefined. If a line is not horizontal or vertical, then the slope has to be positive or negative. So, you guys have seen rise over run. Hopefully you remember this formula a little bit. But all this formula says is to take your change in y values divided by your change in x values. And if we subtract them, we can get that. I'm going to show you 2 ways to find the slope here, and then you get to choose whatever one you want. So the first one is you can use the formula. Now we have a symbol for slope, and it's m. I don't know why it's the letter m. That's just what it was chosen as. But m equals y2 minus y1 over x2 minus x1. y2 and y1 stand for your y coordinates. And now it doesn't matter which one you call y2 and y1. I just always call whatever point they give me first, the first one. So this will be y1, this will be x2, and this will be y2. So if I take my second x value, which is 8, and subtract my first y value, which is 6, that's what I get on the top. And then on the bottom, I have 4 minus 3. So I end up with 2 over 1, which is just 2. Now you can use the formula, or here's another trick. If you put the 2 points on top of each other, and it doesn't matter what 2 points, or what point goes on top of each other, you draw a little L through here. This L is going to split things up so that on the top it has your y values, and on the bottom here you're going to put your x values. So remember, we want to find the difference in these two. So what we're going to do is subtract. So -2 minus -2, and then down here -4 minus 0. And then this just turns into a positive, so we end up with 0 on the top divided by -4 on the bottom. And 0 divided by 4 is 0. Let's do one more. Let's do 5a. So if I have these 2 points. Remember, it doesn't matter which one you have on top and which one you have on bottom if you do the little trick. You can draw the L through them. Here we're going to do 3 minus 7, and out here we'll do 6 minus 6. So you end up with -4 on top this time and 0 on the bottom. And remember, you are not allowed to divide by 0, so this is undefined. So you should know what these pictures represent. If something has a positive slope, that means when you read it from left to right, it goes up. Negative slope is exactly the opposite. As you read it from left to right, it goes down. Every horizontal line has a slope of 0, and every vertical line has an undefined slope. Here you will find 0 on top of a number when you do the slope formula, and here you will find 0 on the bottom. And remember, that is not allowed. So let's go backwards. If I tell you what the slope is, you should be able to fill in this other part of a point. So for this, remember the slope formula, y2 minus y1 over x2 minus x1, and just plug stuff in. I know slope is -5. My second y value is -4. My first y value is 6. Divided by my second x value, which I don't know, so let's put the r, minus my first one, which is a -2. So just like any other time, let's simplify this. This turns into -5 equals, it'll be a -10 over r plus 2. And now think back to when we solved for portions like this. Remember, we can turn this into -5 over 1, and we can find cross products. So the first one's easy, 1 times -10, and then we'll do -5 times r plus 2, and then this just turns into a big algebra problem. I add 10 to both sides, I get 0 equals -5r, and if I divide both sides by -5, we end up with r has to be 0 in order for this to work. So I made it so these 2 points, if I make this a 0 here, would have a slope of -5. So if you notice, I have left a few of them for you to do. So this is using rate of change to solve a problem. See if you can do this last one on your own that we didn't. And these, oh no, we did that one. This one and this one. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.